Okay, welcome back. So any thoughts about what do you think if we change a different values of epsilon, what do you think the utility will change in what direction? Like say if I increase my epsilon, how do we expect our utility going to change? And why? Yeah, Sarah?
My understanding was that the higher epsilon, so the higher the privacy budget, the less noise you need to add to satisfy it. So I would then assume that the higher the privacy budget, the higher the utility, because you're probably adding less noise.
Mm-hmm. Everybody else agrees? Okay. So sounds good. So the only thing I will add is in our previous discussion, especially about the Laplace mechanism, we saw that the relationship, right, of the scale, how the scale of the Laplace was delta f divided by epsilon, right? So there we have the understanding that the higher, in the original definition, the higher the epsilon, which means that the higher the privacy budget, the less noise we need to add. And that's in the context of adding noise, right? And that's when we talked about the original definition of differential privacy, when people usually use it to add noise to the summary statistics. Here, we won't say adding noise, but it will have the same effect, okay? Meaning that, well, if the privacy budget is higher, I mean, I think that's probably one main reason why people call it as privacy budget in the first place. That if you have a higher budget, well, you're more flexible, I guess, in many sense. And then in our context, we'll have higher utility. And one way we can look at it, just to keep us on the thought here, look at how the minimum of alpha are going to change if we increase epsilon based on the expression of alpha. So let's just say we increase epsilon, right? So this term going to increase, right? So the denominator will increase, right? So the minimum bound of this ratio that we have going to decrease, right? So the minimum of alpha going to decrease. And then let's look at what the alpha, so keep in mind, when epsilon increases, the minimum of alpha decreases. So look at what we are doing here. Let me see if we have it. Sorry, I have to go even before the proof, I think. Yeah, here. If we come back to the procedure that we covered earlier. So as epsilon increases, alpha decreases, right? So when alpha decreases, what does that mean from the Bayesian point of view? Let me do this. Okay, so we're saying that when epsilon increases, when we have a higher privacy budget, alpha decreases, right? Okay. Y is never changed. Y is the data. Y vector is the data, okay? So if you think about alpha, again, as a prior sample size, whatever you think of it, it's the influence from the prior, right? So when you have higher privacy budget, mathematically, we can see that the prior influence of alpha are going to decrease. So things will be driven more by the data. And then based on our understanding now, well, the more influence the data are going to have, the resulting synthetic data are going to have will be closer to the original data, right? Like say, if you don't have alpha at all, say alpha is gone here in equation 6. Well, essentially we're generating theta from the data in some sense, right? And then that will intuitively gives us the highest utility because we're using only the information from the data, right? When your alpha decreases, or in the extreme case goes to 0. But if you have larger alpha, which means that if my privacy budget is going to decrease, I have less privacy budget, I have to increase my alpha like crazy. You can try it later if you want. Like say epsilon, I chose it to be 5 to give you the demo. But if you go to say like epsilon equals to 1 or 0.1, well, alpha value is going to be crazy in the hundreds or in the thousands. And then that's swiping all of the information from the data. Because y is what? Even though y is not small, like some of the y's are not small, right? When we look at the value, we saw it, I think, here. Yeah, so only focusing on this here. This is the actual y, right? So imagine if we have super large alpha that we're adding like in the 1,000 or in the 1,000, let's just say it's 1,000 for each of this. Then even though in the data it's highly favoring level categories 1 and 2, when you add super large alpha to each of this, it's going to be flat, right? The Dirichlet vector that we're going to have will be very flat, meaning that, well, at that point, all of them are going to be equally likely. So the utility is going to be super low. Okay. So again, I think this is a nice way to think about what the effects are of this alpha and then of this epsilon. And the end of the story, I mean, again, is not that different from what we saw before. The higher the value of epsilon, the higher the utility, okay? But I want you to not only intuitively guessing it, but also look at how we are actually generating the theta, right? And then later on, the y star, and see it in action given our understanding of Bayesian modeling, okay? Alpha is carrying the information of the prior. And if the prior is super strong, then whatever the information that is carried by the data is wiped away, okay? And then that naturally will give us really low utility. And if you ever want to try epsilon to be 1 or 0.1, you're going to get crazy utility. Every category is going to have similar count. And then we know that that's not high utility, right? So, so keep that in mind. I mean, this is, I think, a nice takeaway message in terms of thinking about what are each pieces doing in the entire process. And if you're ever interested, people have been working on, as you can see in the reference here, how to generate or how to develop differentially private beta binomial synthesizer. And also gamma Poisson is another popular conjugate model that we know for counts, right? So people quite recently actually worked on how to turn that into a differentially private synthesizer that you're able to generate differentially private synthetic data from it for counts, right? So I think personally, I mean, I think this is definitely one of the futures of how this field is going to go, okay? Is differential privacy starts to become, I think, the gold rule of how people think about privacy. But then originally or in the past, people mostly in the last decade or so, or 15 years, mostly people work on summary statistics, okay? Like Laplace mechanism is the first one being proposed, but there's so many other mechanisms that they're generating random noise from it and then add to the output, okay? But from a statistics point of view, I mean, for people like us or the end users of data, they probably not only just want a summary statistics, right? They probably want access to the actual data so they can do the analysis that they want. So that's why I think it's very promising, whatever the work that we saw before and we have been doing, and also in the literature, people have been doing Bayesian synthetic data is still very promising. But of course, how to make those satisfying differential privacy is the key, and it's not easy to do that, okay? So personally, I feel like more statisticians should go into this research field. So, well, more human power and manpower, whatever available, will be able to move this forward. But to me, I think this is definitely one of the very promising research areas. I mean, if you think about privacy protection, if you think about how statistics is playing a role, we're not just thinking about like output of queries and all that. We want to use models, right? If we are equipped with really powerful models to begin with, like the ones that we looked at so far and the ones that you're working on for your project, those ones, if we can make them into satisfying differential privacy, then a lot of the results will be much more accepted out there. Okay, so next week I will also just take the first half, hopefully less. Sorry again, I'm always going over time. but hopefully to give you an overview of some of the ongoing research that I've been working on with some collaborators of how to generating differentially private synthetic microdata. Okay, that's when we're trying to generate synthetic values of, say, income individually. Okay, and how can we satisfy differential privacy in that way, and how we evaluate utility and all that. Okay, so any questions, comments, and feedback? We'll have one more lecture last week and next week, of course. But like I said, that's what we're gonna talk about next time.